Study Guide 7, page 2. Number 12. The two triangles are similar. That means they're the same shape but different sizes. And they give you some measurements. So AC, that's this distance right here, is 2 feet. And BC, which is down here, is 4 feet. GF, which is down here, is 5 feet. And they want to know EF, and I'm going to call that my X, my unknown value. The sides of similar polygons are proportional. So if we match up the sides that go together, we can set up a proportion. 4 is to 5 as 2 is to X. You got to go the same direction. I'm going 4 to 5, 2 to X. Now, that's a proportion. Easiest way to solve it would be to cross multiply, and that's not the only way, but sometimes that's probably the quickest. And we have 4 times X is equal to 5 times 2, and I'm going to go ahead and just do that arithmetic. Solve for X, divide by 4. Now, 10/4, you could write it 5 halves. You can write it, and because we're talking about measurement, we usually don't leave that as a mix, as an improper fraction, so let's do it 2 1/2 feet, or we could do it as 2.5 feet. So really the best two answers would be either this one or this one. Oops, slide that over for you. Okay, power of a power. That means that everything in here is going to be raised to the third power. Now think about what it means, like 3 to the third. 3 to the third means 3 times 3 times 3, which is 27. And we'll go ahead and do that. Now if you have d squared to the third, that means d squared times d squared times d squared. Now do we see a shortcut? Sure. We have 2, 4, 6 d's. And look where that 6 came from. You can multiply those. So we just say 2 times 3, so we have d to the 6. You've got e to the 4th to the third. 4 times 3 is 12. And f, now don't forget that f is raised to the 1, so 1 times 3 would be 3. Number 14, graph each on a separate number line. I'm going to try to draw those underneath so I have a little bit extra room. I could probably do this one over here. X is greater than -3. So let's draw a number line. And I need -3 on my number line, so I think I'm going to, usually when I do negatives, I count from the right. So I think I'm going to do 0 over here, and then -1, -2, -3, -4. I like 3 or 4 numbers on my number line. So I'm going to put 0, -1, -2, -3, -4. So the beginning point is -3. Now we have to decide if -3 is true or false. We only shade the true. So is this point right here, is -3 greater than -3? No, they're equal. So to show that it's not true, we leave it circled. We only shade in what's true. Now where are the numbers bigger than -3? -4 is smaller, so if x is greater than -3, then all of these over here are going to be shaded. They all have solid dots over them. Now this one says m is less than or equal to 8. Let's draw a number line, and I'm going to put, I think I'll do like 6, 7, 8, 9, 10. Just put enough numbers to where we can kind of get a kind of a landmark set. You can get a beginning to see where you're talking about your numbers. If you just put one number on there, it's hard to know exactly where you are. Well, we're going to start at 8, and we've got to decide if 8 is going to be shaded in or not. So is 8 less than or equal to 8? Well, now 8's not less than 8, but notice I said less than or equal to it. 8 is equal to 8, so that's the part that makes it true. And we want the numbers now that are less than 8. Well, we know 7 is less, and 6 is less, so we're going to shade to the left. Now, a trick that we talked about is when the variable's on the left, your shading will go the direction of the inequality. But now that's a big rule. It's very important that you know that only works when the variable's on the left. Write the first 4 terms in arithmetic sequence. That means we're adding where the a sub 1, that's the first term. is -4, and the common difference, that's the number you're adding, is 5. So let's put us 4 blanks. 1, 2, 3, 4. It tells us the first term is -4. So the common difference is what you're going to say. So we're going to say plus 5, which would be a 1. Plus 5, which would be a 6. Plus 5, which would be 11. And they asked for the first 4. They gave us the first one, so we really just had to do the next 3. Number 16, what is the percent increase from 50 to 78? Percent change, in this case increase, is how much they change over the original number, which is the first one. So the first one's 50. We'll put him right here. And we want to know how much these have changed. Well, 50 to 78, if you subtract, is 28. Now, there's multiple ways to change 28 over 50 to a percent. You can divide 50 into 28. Probably the easiest in this case is to multiply by 2 over 2, which is 56 over 100. Because percent is based out of 100, that's 56%. Number 17. 35% of what is 20. You can't do a percent unless you change it to a fraction or decimal. So I'm going to use the 0.35. So I'm going to say 0.35, 35 hundredths, of, which is times, x is my equals 20. Well, you have 36 hundredths attached to x, so we need to divide both sides by multiplication, so we're going to divide. And our 35 hundredths cancel, and we get x is equal to this division. So let's divide 35 hundredths into 20. Well, we're going to need at least 2 decimal places to get it to even divide, and then we'll see how much we need to carry it out to either do repeating or ending. We'll just have to see what happens. So 35 into 20 won't go. 35 times 2 is 70, because it can go more than that. 3, 4, I believe 5 will probably be too big. No, maybe not. Let's see. 15, 25, 15, 16, 17. And then 35 times 6, 18, 21. So 5 is the number we need. And it goes 175 times. Okay. Subtract, have to do a little borrowing here. And you've got 5 from 10 is 5, and 7 from 9 is 2. And bring down your 0. So 35 will go into 250. We said it would go 6. Let's see if it'll go 7 times. 21, 22, 24. Yes, it will. So we've got 7, which is 245. Subtract, we get 5. So we're going to add a 0 and bring it down. And 35 goes into 50 one time. And do a little subtracting, borrowing, and we'll get 15. And 35, need to add a 0 and bring it down. And 35 goes into 150. Let's see, it'll go 4 times, which is 140. Subtract, we get 10. It's not going to end. It's going to be repeating. So I think what I'm going to do is I'm going to take it back to this point when I did the 0.35 into the 20 when we move the decimal place over. And I'm going to go back up there and put my 57, 175, 250, 245, and 5. And I'm going to write it as 57 and 5 over 35, which is 57 and 1/7. So I think that's probably going to be easier to write instead of trying to carry 1/7 out, because it will repeat 6 decimal places. So that's probably going to be the easiest way to write that one. Number 18, write the line 5x minus 3y in slope y-intercept form. We had one like that a while ago in number 10. This one's actually a little bit easier. State the slope and the y-intercept. So if I want to try to get my y by itself, which is my goal, I'm going to get rid of the 5x first. And I get negative 3y is equal to, I'm going to commute that, negative 5x plus 15. Now let's get rid of the negative 3. Now we've got a little reducing here. So we've got y equals, negative over negative is positive, so we've got 5/3 x. Positive divided by negative is negative 5. So this one is my slope. It's my rise over run, 5/3. And then my y-intercept, left the t off, is the number here, which is a negative 5. Number 19, what percent of 60 is 24? So I have x times 60 equals 24. I don't think this one's going to be quite as crazy as number 17. So I need to get rid of the 60. And I get x equals 60 into 24. And I believe we're just going to need one decimal place. You just have to be careful when you're writing it as a percent, because 60 goes into 240 4 times. Now 4/10 is the decimal, but it says percent. If you multiply it by 2 decimal places, which is multiplying by 100%, you'll get that that's 40%. Number 20. To multiply with scientific notation, let's put our 2.1 and our 5 together. And let's do our 10 to the negative 3 times 10 to the 7th together. Okay, 2.1 times 5 is 10.5. And then 10 to the negative 3rd times 10 to the 7th, if you add your exponents, it's going to be 10 to the 4th. Now that is a correct answer, but it's not in scientific notation. So let's just take our 10.5 by itself and see how we write that in scientific notation. This number has to be between 1 and 10, which means the decimal would have to be between the 1 and the 0. Well, when you write it in scientific notation, this number is the number of places you moved it to the left, and I moved it 1 space. So if I put this back up here and replacing it and multiply it by 10 to the 4th, see, I can put these two together and I get 1.05 times 10 to the 1 plus 4, which is 5.